7.1, exponential functions. An exponential function is a function that has a variable for an exponent. They actually have a new part to a graph that we haven't talked about before. They have what's called an asymptote. And an asymptote is a line that a graph approaches but will never actually touch or cross that line. So in this example that I have here, that is an example of an asymptote for a graph of something that does not have any transformations added to it. Our little picture here is, this is not actually an exponential function. It's a function that we'll talk about in chapter 8. But Gandalf is there to kind of remind us that these lines will actually get close to but never touch or cross them. So be very careful when you are actually graphing that it does not appear like your line touches or crosses, because that is an incorrect graph, however. Now, these exponential functions, we actually are not going to use our calculator to graph these. You may use a calculator to check your graph, but you should not be using it to actually graph it. And that's because the process for graphing these, practicing it with exponential functions will allow it to be a little bit easier when we get to logarithmic functions, because we don't use our calculators to graph logs. You actually have to show the process of how you got the graph for the log without using your calculator. So, we look at the parent function, and that's where we get what's called the guide points. These do need to be memorized. It would do very well to memorize kind of all of this part down here, because this is not going to be given to you. So the guide points for an exponential function is just 1b, 0, 1, and negative 1, 1 over b. I feel like it's easier for you to remember 1, 0, negative 1, and b, 1, 1 over b. So I'll give you just a second to copy that down. And let's talk about the parts now of this equation. So the A tells you the reflection. So when it's positive, it's on top of y equals k. And when it's negative, it's been reflected over it. It also tells you how it's been stretched or compressed vertically. H is always found in the exponent. It tells you if it was moved left or right. Remember, it's always the opposite sign of what it appears to be. And then K tells you if the graph has been moved up or down. B is the B that's referred to in the guide points. And the B value is the base to the exponent. Now let's think about this for a second. If H tells me left, right, then that means that a transformation has been applied to the X coordinates. And since K tells me up, down, that tells me that that is only applied to the Y coordinates. This is important information on the other side as we get into graphing these. So this table is just meant to kind of help you learn the process. It will not be given to you on any quiz or test, but it is a good idea to use it as you are practicing these. This first one that we're going to do actually does not have any transformations applied to it. It's just kind of getting in the process of labeling some pieces and what the graph will actually look like. So exponential functions can be categorized as either exponential growth or exponential decay, and that all comes back to that B value. When B is greater than or, just greater than 1, then we have exponential growth. And when B is actually between 0 and 1, we have exponential decay. So when you look at number 1A, the B value here is 2. So that represents exponential growth. And the next one, the B value is 4/5. So that represents exponential decay. because it's between 0 and 1. So using that B value, that will help us identify all of our X coordinates, all of our guide points. So we have 1, 0, -1, and then we go back and the Y coordinates become B, 1, and 1 over B. You can also think of the 1 over B as just reciprocal of B. So that when it's a fraction later on, you just flip that fraction upside down to be matched with that -1. So those are the guide points. Those mean that if there's no transformations applied, those are the 3 points that I'm going to use to graph. But let's go ahead and identify what the other transformations are. So the A value, for example, the A value would be found in front of the B, which in this case, since there isn't something there, A would just be 1. And that A value will be multiplied by whatever the Y coordinates are. Since A is 1, multiplying each of these by 1 is not going to actually change anything. So I'm just going to draw an arrow to represent that nothing changed from the left column to the right. Now the H is always found in the exponent. In this case, nothing is being added or subtracted to the X in the exponent. So 0 would represent our H value. And H gets added, remember, since it does left and right movement, it gets added to the X because our X goes left and right. Adding 0 doesn't change anything though, so nothing is going to change once more. And then we need to identify our K value. And our K value actually comes from a number being added or subtracted outside of the exponent and the base. Again, there's nothing there that's being added or subtracted, so our K value is also 0. So I'm going to just draw arrows to represent that nothing happened in this column as well. So don't worry, we are going to jump into some that have some transformations applied to them, but this first one did not, just to kind of get our feet wet. The other important information, and I'm sorry guys, I've got my son here. The other important information that we need to look at when we are graphing these is the asymptote. And the asymptote, like we wrote down on the other page, comes from the K value. So in this case, the K value is just 0. So my asymptote is going to happen at Y equals 0. And we can use ASY to represent asymptote. And it's Y equals 0. It's important that we write it as Y equals 0 and not just asymptote is 0, because that actually is a line. Just like when we were graphing quadratics, we had an axis of symmetry and we had to list it as X equals a number. That's because it represented a Y, a line. So in this case, our asymptote is a line, so we're going to list it as Y equals 0. Now I'm going to be plotting mine just a smidgen above the line, just so that you guys can tell the difference between the axis and the fact that there is another line there, an asymptote there. Just be very careful when you're plotting your points that you don't actually touch that asymptote line. So I'm going to plot our points now in pink. Our ending column here is the points that you would plot. Since our ending column here ended in arrows, that means that I need to go back to the first place that I had points. That's at 1, 2, 0, 1, and -1, 1 over 2. So those are my 3 points. The shape of an exponential function, you can see that it's starting to approach this asymptote line. It's going to run along this asymptote, and then it will get bigger significantly faster. Just like we wrote down on the other page, our domain is going to be all real numbers. And then our range is that Y has to be greater than 0 because it's on top of that asymptote. and does not equal 0 because the asymptote is 0. So it can't actually touch that 0. So it's just greater than 0. Let's take a look at the next one. We already marked that it's exponential decay because that b value is between 0 and 1. Let's go ahead and do our guide points. Remember, those guide points come from b. So I have 1, 0, and -1 for my x coordinates. And then b, 1 over b would be my y coordinates. So I have b, 1, and remember 1 over b is just the fancy way of saying reciprocal. So there's my guide points. Now let's label what our transformations are that happen. So we need to know what is A, what is H, and what is K. A is the number found in front of the base. So in this case, A is -1/3. H is the number found in the exponent with the x. So remember, H is always the opposite of what it appears to be. So in this case, H is +4. And then we have K. K is the number that's added or subtracted by itself. So that would be 3 in this case. So I have -1/3 for my A value. That means that all of my Y coordinates need to be multiplied by -1/3. And you can't really see that that's a negative there, but it really is. It's a -1/3. So there, I'll make it a lot better. So all of my X coordinates are going to stay the same. And my Y coordinates are all going to be multiplied by -1/3. So you can just type into your calculator 4/5 times -1/3, and you should get -4/15. 1 times -1/3, and we get -1/3. And then 4/5 times -1/3 gives me -5/12. Next column, we're going to use these numbers and we're going to apply the next transformation. So this says to add 4 to the x value. So all of my y coordinates are going to stay the same because I'm only dealing with the transformation for the x, the left and right positioning. So 1 plus 4 gives me 5. 0 plus 4 gives me 4. -1 plus 4 gives me 3. And then we have to add 3 to our k value. That's our last column. So we're going to use our green column and add 3 to our y value. So that means that I need to have all of my x's staying the same. So I still have 5, 4, and 3. And remember that when you're adding, you need to have common denominators. So it might be easier for you to actually do your adding for your fractions, since these are fractions, on your calculator. So -4/15 plus 3, and change it to a fraction, and we get 41/15. Then we have -1/3 plus 3, and change that back to a fraction, 8/3. Finally, we have -5/12 plus 3, and change that back to a fraction, and we have 31/12. So those are the points that you're actually going to plot. Now let's take a second before we plot those and put this into our calculator to make sure that it actually matches these numbers here. So we have negative 1/3, 4/5 raised to the x minus 4 plus 3. So when I look at these points, I need to find 5, that's 2.73. 4 is at 2.6 repeating, and 3 is at 2.83 repeating, which if you remember, those are the numbers that we got over here as well. So that means that I know that I did this right. That's what I was referring to when I said try it with the table first and then check your answers. If you just go straight to the calculator, you will get them right for these, but you will have no clue how to do the logarithms. So really, it's a good idea to practice it with the graphs, with the tables, and then go back to the calculator to make sure that you're applying these correctly. So I'm going to go ahead and plot these points now. One, 2, 3, 4, 5, and 2.73. Oops, that got a little high there. And then at 4, it was at 2.6 repeating. And then finally we had at 3, it was at 2.58 repeating. So they're very, very close together. Let's go ahead and get that asymptote in there because that will tell me what my line should go across. So our asymptote, remember, is always the y equals k value. And our k value was 3. So we have 3 going along the line. And you can see that the numbers were getting smaller and smaller and smaller, and that's what's going to happen here as well. And remember, we wrote with our domain, with exponential functions, it's all real numbers. And our range is going to be y is less than our k value this time because it is below that asymptote line. Let's take a look at C. Locate that B value first. There's B. It's bigger than 1, so that represents growth. So our guide points are 1, 0, -1, B, 1, 1 over B. Now let's locate what A, H, and K are. A is 0.25 in front. Now H, there actually isn't an H value because there's no number with the exponent up there, so H is just 0. And then K is the number that's all by itself, so that's -6. Your first step is always to multiply the y value by 0.25. So that means that all of my x values are staying the same. So I have 0.25 times 4 is 1. 1 times 0.25 is 0.25. And then 1/4 times 0.25 is going to be 1/16. You can just type it in on your calculator and write the decimal if you'd prefer that. So I have 1/4 times 0.25. So you can write 0.0625 or you can write the fraction. Okay, adding 0 does not change anything. So rather than recopying all those points, I'm just going to draw arrows over. And then add -6 to all the k values. So 1 plus -6 gives me -5. 0.25 plus -6 gives me -5.75. Notice how none of my x values are changing. That's because the only thing that I'm dealing with right now is the k value. Then we have 1/16 plus -6, and that gives me -95 over 16, or you can write it as the decimal. I really don't have a preference. The reason why I don't have a preference is because this decimal ends, it terminates. I really want you to not round your decimals. So if you're going to write the decimal, you got to write the whole thing, or you can make it as a fraction. And if you type this into your calculator, we have 0.25 times 4 to the x minus 6. Looking at my table, I get the same numbers. So that means that I did it right. There's -5, -5.75, and -5.93. And it went ahead and rounded because it only shows that many decimal places. So I'm going to go ahead and plot these points. So I have -1 and -5.9375. And I made a mistake on this graph. So I'm just going to draw my y-axis, or sorry, my x-axis up here. And ignore this y-axis or this x-axis down here. So when I graph this, I have 1 and -5. 1, 2, 3, 4, 5. 0 and 1, 2, 3, 4, 5.75. And -1 and -1, 2, 3, 4, 5.9375. Let's find that asymptote. The asymptote is y equals k. So our k value was -6. So -1, 2, 3, 4, 5, 6. Now, if when you are graphing your asymptote, you find that it cuts your points or goes through your points, that means you probably did your points wrong or you have your asymptote graphed wrong. So it's kind of a checks and balances. You do have to include the graph of your asymptote every single time. So we're going to run it just along that asymptote, being careful not to touch or cross it, and then it goes up. The domain of an exponential function is all real numbers. And the range comes from that k value. Since my graph is on top of the k value, it's going to be y is greater than the k value. Let's do another one. So looking and locating that b value first, that's going to be key. Here's my b value. It's between 0 and 1, so that represents the k. And my points, 1, 0, -1, b, 1, and 1 over b. Remember, 1 over b is just reciprocal of b. Now identify h, k, and a. So a is 3. It's the number up front. H is positive 3. Remember, it's always the opposite of what it appears to be. And then k, there isn't one. There's nothing being added or subtracted outside of the asymptote, outside of the exponent. So k is 0. Now we're going to apply our transformations here. So our first step is we're going to multiply all of our y values by 3. So all of our x values are staying the same. And I have 2/3 times 3, which gives me 2. 1 times 3, which gives me 3. And then 3/2 times 3 gives me 9/2. Next, we're going to add 3 to all of our x values. So that means all of the y values are staying exactly the same. We're just adding 3 to each of the x values. So that becomes 4, 3, and 2. And finally, we have to add 0 to all of our y values. Adding 0 doesn't change anything, so I'm just going to draw an arrow over to represent that nothing happened. So when you draw these tables, I do ask that you always have 4 columns and just use arrows to represent that nothing happened. So we're going to plot the points in the last column that we actually wrote numbers in. So that would be 4, 2. Then 3, 3. And 2 and 9/2. Again, you can use your calculator to make sure that you did this right, but I do encourage you to do it by hand first. You're really not helping yourself if you're not going to do it by hand first. So in looking at my table, I'm going to go all the way down to 4, 4, 2, 3, 3, and 2, 4.5. Now let's identify that asymptote. Asymptote is at y equals that k value, 0. So let's graph. Again, I'm just plotting it just a little bit above, just so that you can tell that there's something there, using our dotted line here. I'm going to connect the dots now. Domain and range. Your domain, it's all real numbers because it's an exponential function. Goes out in both directions forever. And your range, it's on top of the asymptote, so y is greater than your k value. Flip it over here. This time, our b value is just 3. So I have 1, 0, and -1, 3, 1, 1 over 3. This time I don't have an a value. So my a value is just 1. There's not any other number in front of the b. My h value is positive 2, opposite of what it appears to be. And then my k value is 4. So since I'm multiplying by 1, that doesn't change anything. I'm just going to use my arrows. I'm adding 2 to all of my x values. So that means all of my y values are going to stay the same. 3, 1, 1 over 3. 2 plus 1 is 3. 0 plus 2 is 2. Negative 1 plus 2 is 1. Then finally, we're adding 4 to all of our y values. So that means all of our x values are staying the same. And I have 4 plus 3 is 7. 1 plus 4 is 5. And then we have 1/3 plus 4, which again, you're more than welcome to use your calculator. And just make sure you change it back to a fraction. So I have 13 thirds. So when I plot these, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 2, and 1, 2, 3, 4, 5. And then 13/3 is approximately 4.3 repeating. So just a smidgen above. Our asymptote, before I go connecting lines, I want to make sure I've got it. Y equals my k value, so 4. 1, 2, 3, 4. I'm going to draw my line in. Be careful not to just whip your line across here, because this is an example of one that would very easily accidentally touch your asymptote. Our b value was greater than 1, so that means it's growth. Our domain is all real numbers. And then our range, it's on top of the asymptote, so it's y is greater than the k value. And you guys can skip the last two problems.